Venus, the second planet from the Sun, is often called Earth's twin brother because of its similar size and composition. But the similarities end there. With temperatures hot enough to melt lead and overwhelming atmospheric pressure, Venus is one of the most hostile environments known. When we look at Venus, the first thing that jumps out at us is its yellowish and opaque atmosphere. But what makes it that way? Venus' atmosphere is unique in many ways. Dominated by carbon dioxide, which makes up about 96.5% of its entire volume, it is also punctuated by clouds made of sulfuric acid, making it extremely dense and corrosive. This very thick atmosphere exerts a pressure on the surface of Venus 92 times greater than the atmospheric pressure at sea level on Earth. It's like being more than 900 meters deep in the Earth's oceans. And then there's the extreme greenhouse effect. While on Earth the greenhouse effect keeps our planet in a habitable temperature range, on Venus it gets totally out of control. The sun's heat is trapped, heating the planet to unimaginable temperatures. This gives Venus an average surface temperature of approximately 467 degrees Celsius, a temperature that surpasses even that of Mercury, the closest planet to the Sun. And here's the surprising part: even on Venusian night, where the sun doesn't shine for long periods, the temperature remains incredibly high due to heat being trapped by the thick atmosphere. By thinking about the extreme environment of Venus, we begin to appreciate the delicate balance of Earth's atmosphere, which supports life as we know it. Although Venus and Earth are often referred to as sister planets due to their similar size and composition, Venus landscapes reveal a history of geological turmoil and active volcanism. The Venusian landscape is punctuated by a surprising number of volcanoes. It is estimated that there are over 1,600 major volcanoes, some of which are over 200 kilometers in diameter. Although volcanoes on Earth and Venus are similar in many ways, Venusian volcanoes have unique characteristics. Most of them appear to have their origins in hot spots, regions where hot material from the mantle rises to the surface. The tectonic plates so characteristic of Earth do not exist on Venus. Instead, the Venusian surface is reshaped by a process called vertical tectonics. The entire planet appears to swell and wither away with the movement of magma below the surface. Another intriguing phenomenon on Venus are coronas, huge circular structures caused by the movement of magma beneath the crust. These are evidence of geological activity that we don't see anywhere else in the solar system. The big question that remains is, are these volcanoes still active? Some evidence, such as fluctuations in the Venusian atmosphere and thermal anomalies, suggests that eruptions may have occurred in the recent past and may still occur. As we continue to study and send missions to Venus, we hope to unlock more secrets of this volcanically active world. Who knows what enigmas still wait to be discovered under the thick atmosphere of this neighboring planet? Venus has always fascinated mankind, but it was at the height of the space race that we started sending mechanical eyes and ears to explore our mysterious neighbor. From the first flybys of NASA's Mariner 2 in 1962 to numerous Soviet missions like Venera 7, which became the first probe to successfully land on another planet, our curiosity about Venus has grown exponentially. And who could forget Venera 9, which gave us the first images of the Venusian surface in 1975. An alien yet curiously familiar landscape filled with rocks and an orange sky. The 1990s brought NASA's revolutionary Magellan mission. Using penetrating radar, Magellan has produced the most detailed maps of the surface of Venus, revealing its complex geology and volcanism. In the 21st century, the European Space Agency stepped in with the Venus Express. For 8 years, she studied the Venusian atmosphere, weather patterns, and dynamics on the planet's surface. And the future? There are bold plans for more missions, including probes that could navigate Venus' dense clouds and robots designed to withstand the extreme conditions on its surface. Both planets are almost the same size, composition, and are located in our Sun's so-called habitable zone. So why did they have such different fates? Earth, with its abundant life, sparkling oceans, and temperate climate, benefits from a range of geological and biological processes that help maintain a climate balance. This balance is delicate and, as Venus shows us, it can be disturbed. There is strong evidence that Venus once had liquid water on its surface. Some cataclysmic event or series of events has led to its current hellish state. Understanding this can give us insights into the fragility of planetary systems. Furthermore, Venus serves as an extreme example of the greenhouse effect. As we grapple with climate change on Earth, understanding the Venusian climate can offer valuable lessons about the balance of gases in our own atmosphere. Venus, with its mysterious beauty and challenging environment, continues to inspire and intrigue. The more we learn about this enigmatic planet, the more we realize how precious and fragile our own home is. So the next time you look up at the night sky and see the bright morning star, remember the fascinating world that is Venus. Until our next journey through the stars, keep exploring and questioning.